Hello and welcome to Unit 1, Lesson 4, Scientific Notation and the Metric System. We're going to break this video into two chunks, in large part because I can't upload the whole video. So this is time number 3 of doing this. Here we go. Let's talk a little bit about scientific notation. Scientific notation is a way that we can write huge numbers or really tiny numbers. And so what we say in science classes, we often say that it's a way to express very large numbers or very small numbers. It's used when a number is way bigger than 1 or way smaller than 1. And it's also used when we have a number that we can't get in the correct significant figures, and so we can put it into scientific notation to have it be in the correct number of significant figures. Now, there's a couple things I'd like to point out or say about this, and when to use it. I often use scientific notation if the number is way bigger than 1. And the example of that be if the number is bigger than 99,999, then I'll put it in scientific notation.
Miss King, please call the office.
I also will use it if the number is smaller than 0.00000, let's say 1, something like that. So if you have really, really tiny numbers or really, really big numbers, then that's when we would start using scientific notation. So what is scientific notation and how does it work? Well, there's this general template where we have a value that we call an M number and an exponent that we call the N value. Now, the M number itself is a number that falls
Mr. Dodge, please call the office.
is a number that falls between 1 and 10, but it can't be 10. So it could be like 1, or it could be like 2, or it could be like 4.5, or it could be 9.99999. It just cannot be 10, and those are kind of the rules. Whereas N is a whole number, and it's the number that we move the decimal in order to be able to get to the number to be between 1 and 10. So let me try to explain that a little bit differently or a little bit better. So N is a whole number. It's a number of places that the decimal was moved. It can be a positive value or it can be a negative value. Now, it's positive when the number is way bigger than 1. Okay, so if I look at this example here, I have 234,500,000. Okay, that's a number way bigger than 1. And the way that we go ahead and put that into scientific notation is I say, well, where would the decimal be? Well, the decimal in this case would probably start right here. Okay, and I'm going to move the decimal until the value of the number, until the number becomes a value between 1 and 10. So if I start here, I'm at 234 million. If I move the decimal to go right there, I become 23,450,000. If I move the decimal here, I become 2,345,000. And if I move the decimal here, I become 234,500. And if I move the decimal here, I become 23,450. Here, I'm at 2,345. Here, I'm at 234.5. Here, I'm at 23.45. And here, I'm at 2.345, which is a number that's between 1 and 10. So this is my M value. Okay. Now, the number of places that I move the decimal becomes my N value. So I moved it 1, 2, 3, 4, 5, 6, 7, 8 spots. So my n is 8, and it's positive. So this number, 2.345 times 10 to the 8th power, is my positive value. Now, if the number is negative, or I'm sorry, if the number is smaller than 1, the n value will be negative. So here we have another number, which is 0.00000002345, way smaller than 1. So if I move the decimal here, I'm 0.00002345. If I move the decimal here, I'm 0.0002345. If I move the decimal here, I'm 0.002345. If I move the decimal here, I'm 0.02345. And if I move the decimal here, I'm 0.2345. Move the decimal one more spot. Look at that. I'm 2.345, which is the number that we're going to record for our m value here. Now, the exponent is going to be 6 because that's the number of places I move the decimal. 1, 2, 3, 4, 5, 6. And it's going to be a negative value because my original number was smaller than 1. So that's how we take numbers and put them into scientific notation. We can take numbers out of scientific notation by looking at this positive value here and say, oh, I got to move the decimal 8 spots, and I got to make the number bigger than 1. And here I have to move the decimal 6 spots, and I have to make the number less than 1. So that's all that's to it. Now, the next part of this is putting scientific notation into your calculator. Now, that becomes a little bit tricky because there's a very specific keystroke sequence that I would like you to do. Now, one of the things that I need to point out here is that when I created this as a PDF, this box was kind of this weird asterisk star space.
Corday Hughes, please report to parent pickup on 64th Street. Corday Hughes, please report to parent pickup on 64th Street.
Now, so those are like multiplication. Now, really what happens is that you are going to take these steps and put this string of numbers into your calculator. And so the calculator that we are going to use when we are in class is this particular beauty right here. Okay. So step number 1 says to type 3.56. So I'm going to type 3.56 into my calculator. And my calculator display is 3.56. So check. Step number 2 is to hit second key and x minus 1. Now the second key is this key right here, and the x to the minus 1 is this key right here, which is above 7. So if I hit second x to the minus 1, I get 3.56, hard to see, E. That big capital E is calculator language for times 10. So the next thing I'm going to do is I'm going to hit 7, and when I do that, my calculator display says 3.56 E7, and the next thing I'm going to do is I'm going to hit the multiplication sign on my calculator. And when I do that, the display says 3.56 E7 times. Then I'm going to go ahead and type in 9.1 on my calculator. And so I should check that off. And now I'm typing in 9.1. And when I do that, my display is 3.56 E7 times 9.1. I'm then going to hit that second key. So here's that second key again, and the x to the minus 1, which is this key right here. So I'm going to do that, second x to the minus 1.
Buses are pulling in 2 minutes.
And when I do that, it says 3.56 E7 times 9.1 E. And so that's this step right here. And then I'm going to hit 3. And when I do that, my calculator then says 3.56 E7 times 9.1 E3, and then I'm going to hit equals, and my calculator gives me 3.2396 times 10 to the 11, which is, I don't know why there's a glare there, but times 10 to the 11, and that's how we put these numbers into our calculator. So what I would like you to do is grab a calculator, and try to put those numbers in the calculator. And if you can do that and you get this for your answer, then you've done it correctly. So I'm going to tell you to pause your video here and try this. And if you get it correctly, great. If not, go back and repeat the steps exactly as I have them listed here and try again. And if you don't have it then, even still, please come and check in with me and we'll get it squared away. Now, Here's another example, and we're going to take a little bit of time for you to plug this in your calculator. So I'm going to pause the video, and we'll see how it goes. Before you get too far, on your note sheet, you should have 8.3 times 10 to the 9, and I have times 10 to the 8 here. That's my bad. Let's use times 10 to the 9. Okay, so if you plug this in your calculator correctly, you should have gotten a number that was less than 1. You should have gotten 0.277 108 434. Now, let's talk about sig figs for a minute. We're multiplying, so we're going to draw an arrow coming in this way, and we're going to see that this has 2 sig figs. I'm sorry, we're not multiplying, we're dividing, but we're dividing, so we're going to draw an arrow coming in this way. This also has 2 sig figs. So my final answer needs to have 2 sig figs. So I draw an arrow coming in this way, and I count 1, 2, draw a line, that's 7, we'll round this 7 up. So my final answer here should be 0.28. Okay. Now, one last thing I'd like to say before I pause this video and go on is that in your notes, you have a 2-column section that looks something like this right here. And ideally, you would be copying these steps down so that you have them so you can remind yourself how to put numbers into scientific notation on your calculator. With that in mind, this is where I'm going to stop the video for now.